So today we're going to add and subtract rational expressions, and we're going to use all of those amazing fraction skills that you have to do this. So first of all, to be able to add and subtract fractions or rational expressions, I must have what? Okay, you got to have a common denominator. Okay, so our denominators have to be the same. All right, so since you were working on these two, then I'm going to go ahead and look at them with you, see if you did them correctly. So letter A, x squared minus 3, x squared minus 3. I got my common denominator. So that means I can write everything over that denominator. Now, when we're adding, much easier than subtracting, because when we're subtracting, we have to do what? Change things, okay? We're going to have to change all the signs, all right? So this becomes 9x plus 4 over x squared minus 3. Now, the one thing you have to be careful of is it possible that I can simplify that? Because sometimes you're going to be able to simplify this. Well, the numerator, there's nothing I can factor out of that, right? And I can't factor x squared minus 3. I mean, I can, but because that would be x plus the square root of 3 and x minus the square root of 3. Okay, how many of you understand that? Okay, all right. Because even though this isn't a perfect square, I can still take the square root of it. It's just going to be square root of 3 and, okay? All right, letter B then. Now, when we're dealing with subtraction, it's tougher because when we're subtracting polynomials, we have to change the signs. So when I do this, I'm actually going to do one more step. Okay? You don't have to if you don't want to, but I'm going to write it in one more step. So my denominator, it's common right now. That's excellent. So I have 3x minus 1. But I'm actually going to write this so I have minus this whole quantity. Because I don't want to forget to distribute the negative, so I'm actually going to write it out first before I do this distributing. Now, if you don't want to do that, you don't have to, but just be careful. Okay. So we have 3x squared minus 5. So I gotta distribute this negative, so it becomes negative 2x squared, positive 3x, positive 2. So 3x squared minus 2x squared gives me x squared. I have a positive 3x and a negative 3. So in this case, I can't factor the denominator or the numerator, and I'm not going to get the denominator even if I did, so I'm done. Okay. But you got to make sure that you distribute that negative. Okay. All right. Now the next thing before we try to find common denominators, before we start looking at those with the common denominators, we need to find what's called the least common multiple. And the least common multiple is basically what's going to be a common denominator for you. So we want to go through the basics of a least common multiple first. Okay. So to find the least common multiple, here's our steps for doing it. Number 1 says factor each polynomial completely. And write any repeated factors as powers. For example, they give us x cubed plus 6x squared plus 9x. That would be x times x plus 3, that quantity squared. Second, it says list the different factors. If the polynomials have common factors, use the highest power of each common factor. Okay, so we're going to start out and look at this with just monomials first. So we have 4x squared y cubed and 6x to the fourth y to the fifth. So what I want to do is I want to factor it, okay? So I'm going to take 4 and I'm going to write it as prime factors, okay? So you remember doing those factor trees? All right, so you might need to do this. So what do I do with 4 if I want to do a factor tree? What do we divide it by, first of all? Why 2? Okay, because it's the smallest prime number, right? Okay, and it's an even number. So 4 is 2 times 2, correct? Okay, and I'm done because those are both prime numbers, right? Okay. So I can say that this is 2 squared times x squared times y cubed. Okay. And 6, if I did it with 6, I would have 2 times 3, right? All right, if I do a factor tree, all right? And those are both prime numbers, so this is 2 times 3 times x to the fourth times y to the fifth. Down there. Okay. All right, now it says list the different factors. So how many different factors do I have there? Nolan, how many different factors are there? How many different characters do you see up there? A 2? Okay, there's a 2, right? There's a 3. What else? X and Y. Okay, 2. So my answer, I have a 2, a 3, an X, and a Y. Okay? Now, what's the highest power of each one of them? All right, Sierra, what's the highest power of the 2? 2. Okay, so I'm going to put a 2 there for the exponent. Okay? Brooke, what's the highest power for a 3? 1. Okay, so I don't need to put a 1 there, do I? Okay. Mr. Keener, what's the highest power for X? 4. Okay. And Mr. Edwards, how about Y? 5. Okay. So my least common multiple then is 2 squared, which is times 3 is 12, x to the fourth, y to the fifth. Okay. So I take each individual factor, list it, write it to the highest power. Okay, and then simplify any numbers you can. All right? Whew. That was difficult, wasn't it? Very. Okay. All right, so I'm going to pause. Shortcut version. Okay. All right. Did all that. Wonderful. Got this answer. Wonderful. Okay. But all you need to do is think of this. Okay. If it's monomials, okay, what is the least common multiple of the constants? Okay. So what's the smallest number that 4 and 6 go into? No. The smallest number they go into. All right. Not the greatest common factor of them. Okay. They go into 12. So 12, and then I just pick the highest power for the variables. Okay. Smallest number 4 and 6 go into is 12. Largest variables, x to the fourth, y to the fifth. Okay? Okay. Or you can do this, which works also. Okay. All right, let's look at this other one with the polynomials then. Okay, so we're going to take each one of these and we're going to factor it. So step 1, factor. Okay, step 2. List all the different factors. Jessica, how many different factors are there up here? How many different factors are there? There are 3 different factors, so I'm going to list them all. X minus 3, x plus 1, and x plus 2. So I look at x minus 3. What's the greatest power of x minus 3? 1, because both of these are to the first power, right? Okay. What's the greatest power of x plus 1? What's the greatest power of x plus 2? There's my answer. Okay. And what we did is that if those were our denominators, okay? So if I had a fraction that had 1 over that plus 1 over that, I just found the common denominator. Okay? So that would be my common denominator if I was adding these 2 fractions together. All right. Okay, so let's add and subtract fractions with unlike denominators. So, and as you told me already, I have to have a common denominator to be able to add and subtract fractions. So step 1, to be able to add these 2 fractions together is going to be, do what? Okay, all right. I need to get them to be the same, but the first thing I need to do is factor. Okay, so I'm going to factor just the denominators. Okay, x plus 4 and x minus 1, right? So now I'm going to put a fraction bar. And in the bottom of my fraction bar, in the denominator, I'm going to list all the different factors from my denominators. Okay? So, Austin, how many different factors are there in my denominators? How many different ones are there? There are 2. Okay, can you tell me what they are specifically? Okay, x plus 4 and x minus 1. Okay, so that's my common denominator. Okay, and those all have the greatest power of each of them is 1, right? Okay, all right, we're good. Now, I look at the first fraction. Okay. Do I have that denominator in my first fraction? I do, right? So then I can just write that down, x minus 3. Okay, I can write down the numerator. Okay. Do I have that denominator in the second fraction? No, because I only have x plus 4, right? So what do I need in that denominator so that they're the same? Okay, I need x minus 1. What do I need to do with that x minus 1? Okay, I have to multiply it by, okay, both the numerator and the denominator. So I'm going to multiply this by x minus 1 in the numerator and the denominator. And then I'm going to write that product in the numerator down here with my common denominator. So 2x squared minus 2x. Okay. I got a common denominator now. I can add my numerators together. So when I add them, I get 2x squared minus x minus 3. And I'm going to leave my denominator factored, okay, for right now. Now, can the numerator be factored? Okay, possibly, right? Okay, it's got an x squared term, so I can possibly factor it. Okay, so I need to factor the numerator now because possibly I have a common factor in the numerator and denominator that I can cancel out, so I can simplify it. Okay. Okay. So I'm going to, above this then, I'm going to factor it. Now, let me ask you this. Abby, is x plus 4 a possible factor of the numerator? No. Okay, because 4 doesn't go into 3, right? Okay. So I know, don't have to worry about that. Is x minus 1 a possible factor of the numerator? Okay, possibly, right? Okay, so I'm going to go ahead and I'm going to write in x minus 1 as one of my factors. Okay. So that means then, Alasia, that the other factor has to be what? 2x plus 3, right? Because 3 times 1 is 3. Okay. Now, is that the correct factorization? No. Right, so I have to test it, right? I have to find the middle term. So when I multiply these together, do I get negative 1? Let's say I get positive 3x, negative 2, which is positive 1, right? Okay, so it's not the same, is it? All right. So since it's not the same, then that's my answer, because I can't simplify it. And I can take this thing here, and I can move it over there because it's worthless. Okay? But I have to check that, okay, to see if I can simplify that fraction any. All right, so we have to go back and do that. All right, let's look at another one. Okay, number 1. Factor. Okay, first thing we're going to do. So we can factor this, x plus 2, x minus 2. Number 2, find the least common multiple or the least common denominator, okay? Carly, what's my least common denominator in this case then? You're really lost right now, okay? All right. So the second step then is to find the least common multiple of the denominators. Okay? So that means I'm going to list all of the different factors. And in this case, there are 2 different factors. I have x plus 2 in the first fraction, x plus 2 in the second fraction, x minus 2 in the second one. But there's only 2 different ones. So I'm going to list those 2 different fractions, or factors, excuse me. Okay. Step 3 then. Let me see. What do I say this for step 3 then? What do you tell yourself? Now, what are you going to do? Okay, so you're going to multiply x times x minus 2, right? Okay, so I'm going to multiply the other fraction by what it doesn't have. Well, that's real good mathematical terminology, isn't it? Okay. Is that what you think about? Is that what you're thinking then, Colin, when you said that? Okay, all right. Jessica, is that what you think? Okay. All right, so we want it to be words that we understand, right? Okay. All right, so the third step is multiply fraction by its missing piece. Does that work?
Sure.
Okay. Does that make sense to you?
Yeah.
Okay. Nolan, does that make sense? Okay. All right. So I'm going to multiply this over here by x minus 2 over x minus 2. So we get x squared minus 2x minus 8. All right. Okay. Oh, this is nice. It's already simplified. But, all right. Factor numerator if possible. So x minus 4, x plus 2, x plus 2, x minus 2. Okay. Step 5, simplify. They both have an x plus 2. All right, so we get x minus 4 over x minus 2 for my answer. But you know what? I think I forgot something. I knew I did. Identify any x values for which the expression is undefined. And guess what? This is really easy because you guys are really smart. We've already factored, so x cannot equal what?
4 or 2.
What makes the denominator equal to 0? Remember, we have to go back to the beginning and look at our factors from the beginning. Okay? And our factors at the beginning were x plus 2 and x minus 2, right? So that means it cannot equal plus or minus 2. Remember, we're going back to the beginning. All right? All the way back to the beginning. So, since we forgot that up here in the first one, I suppose we better say what that is. So up here then, let's use another color. Let's go purple. X cannot equal what here? You guys are awesome. You rock. Okay, -4 and 1 in unison also.